Hello and welcome to another episode of TWIML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. My guest on the show this week is Danny Lange, Vice President for Machine Learning and AI at video game technology developer Unity Technologies. Danny is well-traveled in the world of ML and AI and has had a hand in developing machine learning platforms at companies like Uber, Amazon, and Microsoft. In this conversation, we cover a bunch of topics, including how ML and AI are being used in gaming, the importance of reinforcement learning in the future of game development, the intersection between AI and augmented and virtual reality, and the next steps in natural character interaction. But before we get to Danny, does anyone want to guess what today is? Well, not really today, but tomorrow. And well, unless you hear this on Friday, May 19th, not even really tomorrow for you. In any case, what I'm trying to get at is that tomorrow is a very special day for the TWIML family. Yep, you guessed it. Tomorrow, May 20th, is the 1-year anniversary of This Week in Machine Learning and AI. I started this podcast last year as a way to share what I was learning about the field, and to be quite honest, I really had no idea what I was getting into. But what an amazing ride it's been. The amount of interest in the podcast has been incredible, and I could not be more appreciative of and impressed with the TWIML listener community. Thank you so much. We've been working really hard to be worthy of your attention by continuing to bring you amazing content that you can't find anyplace else. While we usually mention our quote contest now, which was inspired, by the way, by TWIML listener Beth Ann Noble, I'd like to do something special this time around to celebrate our birthday. This week, we'd like to announce a very special listener appreciation contest to honor the occasion. First prize in this contest will be a bronze pass to the upcoming O'Reilly AI conference in New York City, valued at $1,800. I'll be there, and I'd love to have you there as my guest. Second prize is a brand new Google Home powered by AI. You know you can listen to the podcast on these, right? And of course, every entrant will win a couple of stickers, one for you and one for a friend, and of course, our everlasting love and appreciation. So how do you enter? Well, it's easy. Leave us a review on iTunes or comment on this week's show notes page. That'll be at twimlai.com/talk/24. Telling us about your favorite TWIML experience, the things you've learned, your favorite moments on the show, etc. It's that easy. We'll select the winners on June 1st and announce the winners on the next show. We'll have an alternate prize available for first place winners who know they can't attend the O'Reilly event, which will be of similar value as the second place prize. But the details here are TBD. All the contest details will be available on the show notes page, so click right over, or better yet, jump into your podcast app right now and leave us a review, and wish us happy birthday. One more quick note before we get to Danny. The Future of Data Summit was earlier this week, and wow, it was really an amazing event. The speakers were just outstanding. Obviously, most of you couldn't make it to the event, so I'm working with the Interop conference to see if I can publish the session recording someplace, and I'll let you know if I can. Okay, and now, on to our show. Hello, everyone. I am on the line with Danny Lange. Danny is Vice President for AI and Machine Learning at Unity Technologies, and I'm super excited to have him on as a guest. Danny, why don't you say hi to the audience?
Hey there, and thanks for having me.
Absolutely, absolutely. So why don't we start by having you tell us a little bit about your background? You have quite an impressive background in this field, having built platforms at pretty much all of the places that are, or many of the places that are doing very cool things with ML and AI. Why don't you tell us a little bit about that?
Sure, yeah. I joined Unity Technologies about 3 months ago. I saw gaming and VR and AR as a huge opportunity to go in and change it through AI and machine learning. But I think we'll talk more about that in a moment. But before joining Unity Technologies, I was head of machine learning at Uber, which is a complete different business. Yeah, at Uber, we used machine learning basically all over the company. There were three really big areas. One was drivers, riders, and trips, where we use machine learning to give you a better experience, both as a driver, as a rider. And then there's the whole map business of building maps for the Uber drivers. A lot of machine learning there to basically convert street side imagery and other data into maps automatically. And then the last area is of course the famous self-driving cars. Was involved in that effort as well. A lot of machine learning there.
Of course.
Yeah. And before Uber, I was general manager for machine learning at Amazon, and it's also very, very interesting to see how Amazon really understood to use machine learning in all corners of the company. I ran the Elastic Machine Learning team, which was essentially a platform that other teams could use to enable machine learning in their specific business areas. So we had, lots of teams using machine learning that way. And before that, I was at Microsoft. I was also working on machine learning there. So it goes on and on. Many years ago, I spent 8 years in 2 different startups where we were trying to build virtual assistants, the ones that we know today as Alexa and Siri. We tried to build them at that time for the early mobile phones.
Okay.
And, that was pretty tough because the speech recognition at that time maybe had an accuracy of 80%. Today, what is it, 95? So those were hard times to do AI because it didn't seem very smart.
We've made a lot of progress.
Oh yeah.
Okay, and so how did you get into machine learning in the first place? Did you study it in school?
No, early on. This is very long, so long time ago. I don't want to talk about it. But I got in when I was at IBM Research. My key area was autonomous agents. So it was a lot of the vision of having software that would make decisions on its own. You would let it loose. I developed what we called mobile agents, and it was basically software objects that could move over the internet and adapt to local environments and things like that. But it was all sort of fairly engineering heavy development. Yeah, we designed these, we implemented them, and if you had a bug in there, it would get stuck on another computer and not move on and things like that. So I got really interested in how you could make these agents more resilient. And that's sort of where we're headed today with machine learning, with concepts like reinforcement learning and other technologies that allow these objects to learn and adapt to the environment they're in.
Okay. Well, that is a really interesting topic, and one that we won't dive into right now. Where I really wanted to go with this is, we've talked about a lot of different applications of machine learning on this podcast, but we've never talked about gaming. And so I'm super excited to have you on to really dive into how ML and AI are being used in gaming environments right now. What's the best way to start that discussion?
Yeah, let's start out by just acknowledging that whether it's at Microsoft or Amazon or Uber, it's the same kind of technologies that we're using. It's the same algorithms, the same concepts, yeah? And you would be surprised that when you move into gaming, we again are going to use the same technologies to bring more automation in. So to have the games optimized, have the games interacting more closely with you. It's in many ways the same approach the same technique as when we at Amazon try to basically sell you more books. Yeah?
Right.
It's this idea that the systems will learn from you and they will adopt. It's this idea that no developer can sit down and code, 100 lines of code and then it knows exactly how to get you to buy a book. It's sort of the same concept that we want to bring to the game world.
So there are, I guess I would describe that world in two broad categories. There's machine learning and AI that happens in game, and then there's all the stuff that many other companies have to deal with, in terms of making people more likely to play the game and optimizing, selling the game, and things like that. Are you involved in both sides of both of those categories at Unity?
Exactly. My job is really two jobs. So one part of my job is to make sure that our many, many thousands of game developers can monetize their games, that they can make money on their games, so that they can develop more games. Yeah. So we support an advertisement infrastructure. We use machine learning to optimize the ads, which is essentially, bringing a gamer from one game to another game, and the creator of that game then will make some money from that. Yeah?
Okay.
And that's a classical monetization through ads structure. There's also in-app purchases where you will spend money within the game, running campaigns and promotions. All that is what I would call sort of very classical machine learning. And it's super important for the ecosystem to be able to make a living from making games. Yeah, it's very important for our developers. That's only half of the story. The other half of the story is really when it comes to the creation of games. And that's where AI in the gaming world means something slightly different from when I'm using the word AI. Yeah.
Okay.
So a lot of concepts in the gaming world is AI means having systems that look and behave in a natural way.
Right.
It's rule-based systems that allow an NPC and a non-player character or a computer agent to move around in a game, and it looks sort of reasonable, sensible what it's doing. But a lot of that is either hardwired or coded through a set of rules.
Let's actually, if I can press the pause button there, this is a question that I've had asked before. We've had, in games going back to, my Atari 2600, right? You have the ability to play against the computer. Is that AI? And you were just kind of getting at this with the rule-based and others. What's the difference between that and, where we're trying to get to today?
Yeah, that's actually a good question. It is not what I understand by AI, but it has elements of it. Yeah, it implements behavior through rules or really, deterministic hardwired code. It implements behavior that may emulate a human player. Yeah, but we want to take that a step further. Yeah, that's not the way that companies like Amazon or Uber works. Yeah, when they try to sell you more products, or they try to get a car faster to you, that is basically done through the use of data. Yeah,
right.
That's where we want to move the game world. We want to make sure that games learn from previous plays and become more and more natural in their interaction with the player. Yeah, and that's where concepts like machine learning come in. Yeah, I can give some examples of a particular branch of machine learning, which is called reinforcement learning.
Okay,
and that's essentially where the computer has this ability to randomly move a character around and learn from that what happens to that character. Yeah. So if you tell the computer that character should not get killed, it should be avoid getting shot by the human player, then the character will over time, basically learn behavior and strategies to avoid getting shot. Yeah, so we basically say the character has a rewards function, which is you get punished if you get shot or hit, and you get a plus point, for every minute you survive. Yeah, so with the recent developments in deep learning, these agents are able to learn some really complex strategies on their own that make them very, very appealing to play against. Yeah.
And so if I'm a player of a game that's, using an AI-based agent that I'm playing either with or against, how will that feel different to me than, what I've seen with traditional, automated opponents or players?
Yeah. The traditional systems are what we could sort of call very shallow. They implement very simple functions, whereas with this concept of deep learning, we're able to implement, or the system is able to represent very, very complex nonlinear functions. So let me give some examples. When DeepMind introduced AlphaGo, it did beat the world champion in Go, and the way it did that was basically by playing some moves that initially looked really harmless, that did not get the human opponent's attention, but certainly in very few moves set the human opponent up for failure. Yeah. So we have seen another example of poker playing using deep reinforcement nets for poker playing, where the system will learn to bluff. So the big difference is that these systems, and I use the term deep here, they're deep in the sense that they have a very good memory of events way back that eventually leads to great success. So they become more strategic than we're used to. In some cases, they become more strategic than any human player would be. Yeah? So they're ready to run the risk, like in poker. They actually run the risk of losing by bluffing because they know that there is a bigger benefit out there.
And not because they were programmed to bluff every so often, but rather because they've discovered this strategy through the training process.
That's accurate. Spot on. And that's the new thing. That's what we're able to do today. And that really changes a part of game development to become more about defining the objective or the success criteria for that NPC. Because let's just say that we define it as thou shall not get shot. Yeah, then the agent will really, be really good at hiding. Yeah, and you will get really good at it. Yeah, or just getting away in time every time you try to find it. Yeah, that's not fun. Yeah, so what you have to do is you have to set up some criteria for that NPC that eventually will allow it to develop some subtle and complex strategies that you cannot predict per se, but we know will lead to some very, very appealing behavior that will give great enjoyment to play against, because they are maybe hard to predict. Maybe you constantly think you're about to have this agent and then they fool you, and then it becomes very entertaining. Yeah, and that's what we have seen, that these very deep nets through reinforcement learning can really build up these very complex strategies that sometimes I saw a quote from one poker player who basically stated that if he didn't know better, he would characterize that as a really like a human spirit in that gameplay. Yeah. Yeah.
So I think the popular examples of or at least the celebrated AI successes have been around these strategy board games like Go and chess. To what extent are games like, your Xbox games like Halo or Call of Duty, to what extent are the various agents in those games powered by something that you would think of as AI today?
Today they are powered by what we would call classic game AI. So it's in in most of the cases that I'm aware of, it's very complex rule-based systems. In some cases, way over 1,000 independent rules that have been created by the developers to basically cover a lot of different situations. It's very complex systems. But we saw a similar approach in antivirus programs for a long time. They developed basically databases of rules that would identify, components or elements of virus software. And today, all these systems have moved on and are actually using. A lot of them are using deep learning for training on known viruses to detect, new viruses.
And are you aware of any particular efforts or results that have been maybe published somewhere in terms of introducing AI into these types of games?
No, not in any commercial games. We would, of course, from Unity Technologies side, we would. That's one of our objectives is to offer that sometime in the future. There's a lot of research going on. So if we go to academia, go to the research community, there's a great interest in start working on this. The appeal is, of course, that if I can do this, if I can get an NPC in a game to act in a very reasonable and intelligent and constructive way, then eventually, maybe real robots could behave that way too.
Right. So how do you, as Unity, how do you expect this to evolve? And are there a set of services that you are hoping to deliver to game developers? How do you think this evolves over time so that we'll see it more in games?
Yeah, it's my hope that we can make some of these algorithms available as services, essentially to enable a game developer who is not an AI or neural network or ML guy, some deep AI specialist, but basically a game developer. Make a game developer having a toolbox of AI services that they can use to train a character, and in that sense, sort of gradually enable AI in game development. We have to understand that this is the livelihood of our developers. This is how they make money, and that's how they live. Yeah, they develop games. So what we want to do is we want to give them these tools that allow them to create maybe make it more efficient. They can create some games faster. They can create games that are more entertaining, etc. Yeah. So we want to make that available so that it can sort of gradually be adopted, and we can also learn from the use. Nobody has really done this very much yet, yeah. So we don't know yet how it's going to work in practice.
In some ways, it strikes me that there's a precedent for this, and that game developers aren't typically physicists either, but it's very common for them to work with these physics engines nowadays to develop their games. No?
That's correct. We have actually done some studies where we are using reinforcement learning to have characters learn how to move in a world where there's gravity and friction. Yeah, and inertia, and it's kind of interesting to see how a character can learn, to walk or run or jump without knowing it from the outset, but by basically attempting, tens of thousands of times, and over time you will figure out the pattern of movements to jump, for instance. Yeah.
Mm-hmm.
And in that sense, we're actually using the fact that we can simulate gravity, simulate friction and inertia in the physics engine.
Okay. One question that I've had about the application of reinforcement learning to games is, I guess when we think about machine learning in general, and I don't believe that reinforcement learning is a common exception to this, you've got kind of your two separate stages. You've got your training stage and your inference stage. But in a game environment, I imagine part of the appeal of AI is so that the agents in the game can learn from the game as it's happening, right? So not during a training phase, but during the actual playing phase. How does that is that we've talked about on the show active learning, which may be a part of this, but is there a specific name for that, and how is it commonly done today?
Yeah, you're absolutely right. Yeah, that's where I would love to go. I would love to go. Let me give some crazy crazy examples yet. But imagine that, say that you are playing your Pokemon Go, yeah?
Right.
Where you have to train your character, yeah? Today, the training of that character is not really anything, yeah? You just click a few times and that's how you train it, yeah? But imagine that you are actually training that character to battle. And you could train it for half an hour, 1 hour, and that you are actually teaching a reinforcement algorithm behind the character, yeah, in real time. And if you're really good at training it, it may beat some other person's character, yeah, who was not that good at training it. That's one thing. The other thing is that if the game can learn through gameplay, then it can learn about you. And just like Amazon and Netflix, they basically tailor everything you see to you. I mean, if you go to Netflix, what you see is different from what I see, yeah? It's tailored to you. What if every game in that sense was tailored to you, yeah? If the game knows that you're only happy if you progress fast through the levels, then let's make it easy to progress, yeah? But if the game knows that I'm sort of more rigorous and I want, to fight hard from get to level, then that's a different approach, yeah? What if games could adapt?
Oh, that's really interesting. Yeah, I'd be happy if the games could know that, whenever I'm playing Call of Duty, I'm hiding in this particular corner and make it a little bit less easy for me to just camp out there and snipe on people.
Exactly. Yes.
You mentioned that one of the motivations for you joining Unity was what was going on in terms of augmented and virtual reality. Can you talk a little bit about that and where you see the intersections between AR, VR, and AI being?
Yeah. Now, if you think about a game as you know it today being, it's a very controlled environment, yeah? I can hard code the game. I can add AI to the game, but it's a very controlled environment. Yeah,
right.
When we start moving into VR and AR, we start having a lot more flexibility. So let's take VR a bit. Yeah, now I emerge into a game. I can now move around in the game, and I can pet the characters in the game. I can touch them.
Right.
And when I do that, the bar moves up for what I consider naturalness. Yeah, I may play a game on a phone and I can see the characters are not, they are characters and they are a bit artificial in their movements. Yeah, when I put on my goggles, I want to get immersed into this new world. Yeah, and things have to act in a very natural way with me. Otherwise, the illusion breaks and it's not really fun. Right. And take that a step further in augmented reality, the game, or should we call it the app, because it can be way more than games, yeah? Let's call it the app, yeah? Needs to sort of connect between myself and the surroundings, yeah? And those surroundings can now be anything, yeah? I don't know, you use this app, I don't know where you're going to use it, I don't know what's going to be there. So you see the bar goes up, constantly up, where you can no longer imagine, 1,000 lines of code being the answer to everything. Yeah. So
Right.
that's where you need to have AI really come in. Yeah. And that is of course an area where we can make a big change through AI.
Clearly, I think that makes a lot of sense. The user expectation is dramatically increased because you want this environment to be immersive and engaging and feel lifelike. And so it only makes sense that you're interacting with intelligent things if they're, beings. Do you expect the AI techniques that we use to do this to be the same kind of things that we're applying every place else, or are there going to be a new set of techniques that come into play when we start talking AR, VR?
I think initially it's gonna be some of the same technologies, but I want to say one thing here, which is when we do talk about this of VR and AR, that we are able to push the boundary of AI much further here and much faster. Yeah. If I'm building a self-driving car,
Mm-hmm.
I have to be very careful how far I push the boundaries of AR,
Mm-hmm.
AI, yeah,
Mm-hmm.
because it's a 2,000 pound or more object that may actually kill people if
Right.
I'm not, understanding what I'm doing as a machine learning on AI expert, yeah. So you need to really put a lot of boundaries in. When you build an industrial robot, it's the same. Yeah, it needs to build a car, but it should not, hit the operator around it. So
Right.
there's a lot of hardwiring taking place. When you move to VR and AR, I'm like, you know, how how bad can it be? What harm can you make? Yeah, so you
Right.
can really push the boundary there, yet you create a complete, believable world. Yeah, at the
Mm-hmm.
same time. Yeah, so you give people this experience, and you can push the boundaries of AI to its very limits. And if you go over, people take the goggles off and say, "Nah, that was really bad."
Right.
That was not
Right.
believable. Yeah,
Right.
yeah.
Mm.
And that attracts me a lot to this space here. Because
Uh-huh.
when you sell books or you get taxis around, you are to a great extent limited by the physical world.
Right.
Yeah.
Right.
Now we can really play tricks with the physical world, and if those tricks they fail, we didn't really kill anyone.
Have you seen any interesting implementations or early results in marrying AI and AR VR?
We have done some experiments. I think that this is still emerging technology. There's a lot of things around VR and AR that has not yet really been tried out and not yet fully understood.
Sure.
But I think that very quickly, uh, creators of games and apps in AR and VR are realizing that they're gonna have to step it up a bit because people expect that natural interaction. Yeah. So
Right.
in many VR apps and games today, you can pick up an object and you can maybe throw it. Yeah.
Uh-huh.
But you would love that same interaction with other virtual characters or non-person characters in those games. Yeah.
Right.
And you would
Right.
really like to interact with them, and you want to interact with them in your way, and they should be able to respond in a natural and not, some uncanny way.
Mm-hmm.
And I think we still have some way to go there.
Right. Right. Yeah, I think that may be a bit of a summary of that one bucket, which is the in-game experience and in VR, AR experience. Is it's just super early, and you guys are experimenting, as are a lot of people, but we're still far from Call of Duty X, whatever the next version is, being a fully AI enabled game.
Yeah, that's for sure. The part we are trying to play there is to enable the basic technologies so that our game developers can start playing with it and sort of evolve it and help us understand what works and what does not work.
Mm-hmm. Mm-hmm. And so, how about in the other bucket? where you're applying ML and AI to, more from a business perspective. What are some of the results that you've been able to achieve there?
Yeah, so by basically understanding what kind of games people play, just like what kind of movies you watch and what kind of books you read, you basically understand what kind of games you play. You're able to uh, pinpoint much better recommendations or ads for other games. Yeah, so you will
Okay.
if you always play single shooter games, probably it would be best off showing you some trailers for other single shooter games. Yeah.
Right. Right.
But there are technologies in there that Amazon, that Netflix has been very good at, technologies that basically start exploring uh, your interests, even exploring the things that you maybe don't even know yet that you're actually interested in.
Uh-huh.
So basically using machine learning to better get to know you and your game preferences and make sure that you can discover those games, because there's so many games in the App Store, yeah, or in Google Play, that there's so many games that you can't possibly find all the games that you actually really like. Yeah. So we'll basically learn over time what your preferences are and find those games for you.
What have you found challenging in applying these technologies at Unity? And for that matter, at previous organizations, what are the challenge patterns that you come up with when you're trying to introduce this or mature it in a given organization?
Yeah. That, whether that is Amazon, Uber, or Unity technologies, that it's the same all the way around, and that is that you should not need to be a machine learning expert or an AI expert to accomplish this.
Right.
You should be able to say, my problem is selling more shoes or selling more books or getting taxis on time.
Uh-huh.
Therefore, I should be able to use machine learning services to get there.
Right.
And that's how I thought about it at Amazon, by basically creating as a platform. We also launched the Amazon machine learning system. We launched that on Amazon Web Services for the public to use.
Mm-hmm.
And that is very powerful, because now you get people with real business problems, people with real incentives to improve their business, using these technologies, which are way superior to any attempt of trying to write 1,000 lines of C++ code or whatever to solve the problem. Yeah, basically based on that data, they can train computers to do a better job. Yeah, so in all these organizations, it was a matter of making it available in a meaningful way, and that's what I'm doing at Unity too, is to make sure that game developers do not have to have a PhD in machine learning to benefit from it.
What lessons have you learned in building these machine learning platforms at Amazon, Uber, and now Unity?
There's one big lesson learned, which is that it just works really, really well.
So make it just work.
But no, machine learning does work really well.
Okay.
It does provide results. Period. And there may be a lot of talk about it. There may be a lot of talk about deep learning. Some people call it hype. I'm like, yep, you can call it hype. You can call it whatever you want. But the proof is there that we are able to improve business, where we move from a concept of trying to analyze and investigate and implement to a world where we basically use the data to improve the business through learning. And whether that is selling books, driving taxis, or developing and playing and selling games, machine learning it really works.
You've been talking to different groups about the notion of bringing machine learning to every corner of your business. And to me, that suggests, not just the obvious places, but maybe some interesting places. Do you have any stories or examples of, interesting corners that you have been able to bring machine learning and where you found, interesting or surprising results?
Yeah. I would say that you often run into business problems. If you're selling shoes, one of your key business problems is that people get a shoe online, order it online, they get a shoe and it doesn't fit. Yeah, machine learning is one of these wonderful things where all the return data, all the shoes that did fit and all the shoes that did not fit, if you use that data, you can start predicting how different shoe brands, do they run large, do they run small, are they spot on? You can even start predicting what shoe size a given customer has, yeah? And you can basically use that to give a better shoe purchasing experience. To me, that's kind of a surprise, yeah? I didn't really think about shoes, but that's when you enable machine learning into a non-machine learning environment, you will see business problems popping up. Another one is, imagine, I've seen this being used, I won't be specific, but where machine learning is used within HR to basically complement or one day maybe even replace, performance reviews and things like that, yeah? To predict, to analyze resumes and predict, which candidates may be good and strong future employees.
Right.
So there are areas. It's sort of, to me, because I've always been on the platform side of this. It's. I get surprised almost, if not daily, but then close to daily on what people are using this for. Yeah. And that is really what matters. It matters, let's enable a lot of people to use this technology.
So in order to make that vision real, how do you build the right relationship between the platform people, the data science people, the business people, so that you can kind of build capacity as an organization that uses machine learning effectively?
Yeah, you need to avoid making this a very custom effort for every single team and for every single use. That's what it traditionally, that's where it came from, yeah? You would have a team that would have a business need. You would hire data scientists, you would hire machine learning engineers, you would implement proprietary algorithms, and you would maintain those, and then you would need to hire more people as your business scales, etc., yeah? And one thing that I did at Uber was to build a machine learning stack from the ground up, entirely based on open source. And build it and define it as a platform. Yeah. So what I find over the years is that a lot of teams come and say, I need this feature, I need that feature, this is very important. This is very important for me. I need this other feature, which is even more important for me. Well, That's the wrong mindset, because what they need to do is they need to deploy a lot of machine learning models across their business, rather than just fixating on one particular one. Yeah, and I have often seen this in fraud detection teams. They would have some very custom algorithms detecting, certain kind of fraud. And I sort of compare it to, you have 5 locks on your front door, but you leave all the windows open. Yeah. So these very customized solutions, I think, should be something of the past, because using open source, using standardized algorithms is so much more efficient. So rather than one magic model, deploy 10 or 50 or 100 different models to run your business.
Can you speak at all to the specific open source tools and projects that you use to build that platform at Uber?
Absolutely. It's all public. There are slides around if you Google it. But it's essentially a Hadoop, HDFS, Hadoop, Spark things like MLlib, XGBoost, an open source, very, very versatile open source algorithm from University of Washington. Things like Caffe, TensorFlow, Kafka for streaming, Cassandra for structured data. It's you can get really, really far with all those tools combined without any need for really deep customization.
And so the platform you built was something that made all of these available. And did you put some kind of layer on top of it to, for visualization or automation, or how did you pull all of these disparate tools together?
Yeah, both at Amazon and Uber, the key contribution was essentially defining, a really solid SDK, so people could programmatically integrate with that system.
Okay.
A nice and easy to use graphical user interface, a web-based, browser-based interface. Again, because we want a wide range of users to not feel that the barrier of entry is too high. Yeah? And then, so really the user interface, the SDK side, that's how to access the systems. And then at the other end of it, you need to have the system being able to easily access the data of the company. So you need to integrate on the data side into the data repositories of the company, whether there's existing data warehousing, data lakes, relational databases, etc. Yeah. So the stack is really something I would say is not, the stack itself is not as important as long as it works and runs, but it's sort of that integration on both the front end and the back end into the business. That's important because that lowers the barrier of entry. It makes it easy for you to build a model if you don't have to track down data from outside your team.
On the front end of that, was the primary user experience like a IPython notebook or Jupyter notebook, rather, or were there different ways that developers access the system?
Yeah, there was a total custom user interface. There was also you could also basically use things like Jupyter Notebook. As long as the system has a Python SDK, you can do that integration very quickly. And you can now run your model building jobs from Jupyter. You can visualize stuff. You can deploy from Jupyter. So I personally love Jupyter Notebook. I think it's an incredible tool. A custom user interface, fine too. But most of all, actually, is the SDKs in multiple languages are important because that allows back-end engineers to easily integrate machine learning into their offerings. Yeah, so if you take the mobile app at Uber, when you open the app up, it suggests one or two or three likely destinations that you normally go to. That piece, that was actually a piece of machine learning right there. Yeah, using your data to build models that predict where you're going to go, on a given day of the week at a given time. Yeah.
Interesting. When we spoke previously, you talked a little bit about your vision for really fully autonomous corporations. What does that mean, and what do you envision there?
Yeah. If you follow me on thinking that we can use really deep reinforcement learning to train an NPC or an Go player or poker player, yeah. If we can train a computer to use really deep and complex strategies, including bluffing, if we can train it to do that, then we can probably also train an agent to, say, sell books or sell movies, yeah, and become better and better at it, yeah. I mean, like in the end, it should become the best book-selling agent in the world. Yeah. And you can take that further and say, well, the point, for instance, let's just take an example. Not only which book should I try to sell, but what should the prices be? Yeah.
Right.
So imagine that you use reinforcement learning to figure out what is the right price to sell stuff at. Yeah. And what is the right time to order books at so that we don't run out of book for logistics reasons? Yeah. When should we order the parts to build, our Xbox, our Kindle, our hardware? Yeah.
Right.
If you look at a lot of problems that humans are solving in corporations today, I think many of those problems can be learned and solved by a computer. If you take reinforcement learning, deep reinforcement learning as we know it today, as a starting point, and basically just think a little out there, why not?
Right. Yeah, I think what's interesting about that to me is that we often think about this AGI, artificial general intelligence, as this kind of one uber AI that, is just very human-like and can reason and, do everything. But you're describing something that could create tremendous value that is, much less ambitious, right? It's a collection of AIs that are more purpose built. And we should be able to get there, a lot quicker.
Yeah, I'm kind of struggling with the whole AGI debate. It's sort of maybe, +1 or +2 out there for me. But I do think that there is an interesting perspective in if we envision a world where reinforcement learning, I'm using that as sort of a very general term here, yeah, but there will, be many different variations of it. But we do envision a world where a company like Amazon use that not, just to selling books, not just in 10 places, but they use it 5,000 parts of their company, yeah. They use it everywhere. Yeah.
Right.
And you start having these systems interacting. At one point, when you add it all up, you get more than the sum. Yeah. Because now you're going to get the effect of I'm really good at selling. I'm really good at finding the right price point to maximize revenue. I'm really good at understanding what people want. I'm really good at ordering all the parts and components in time so that I never run out, etc., etc. And suddenly you have sort of a whole product pipeline happening, yeah, with very limited human intervention. Yeah, is that AGI? I don't think people think of that, but is that looking like a super intelligent corporation? Oh
yeah. It strikes me that there's a whole field of study and research that would need to happen to allow us to manage this thing. Like it's almost the application of traditional control systems work to these independent AI systems like hysteresis, so you don't, over or under order or order too aggressively. It's just a whole layer that needs to happen there that we're clearly not there yet.
Yeah, I totally agree with that observation. And I also think that, and we start seeing this in some papers coming out, I do see a shift in some research that now goes more towards researching the strategy around teaching computers, yeah? So basically, examples are like if I give a reinforcement learning algorithm, if I give it too hard of a problem to begin with, it's not going to solve it. Yeah. But if I sort of give it, increasingly difficult problems to solve, it gets really good at it. Yeah. So that's kind of learning strategies, and so we're not talking about the technology here. We're not talking about this particular structure of a deep neural net or something like that. We're just talking about how do I best teach a computer. Yeah. And that company is looking at how can I minimize the need for data, because data can be difficult to get by. So it's
Right.
a way I can learn more efficiently. So if you think about some of these research topics are kind of at a meta level. Yeah, so far we have been so eager to study algorithms and methods, but maybe a lot of the future research is really about what does a good school for computers look like.
Interesting. Well, as we wind down, any parting thoughts or words for our audience?
I think that the audience should look at the gaming and the gaming platforms as a fantastic lab for AI that's going to give us a peek into the future. Because if you think about NPCs moving around in a game, they are really robots, yeah? But
Right.
robots in the physical world, they take, easily a year to 2 years to build. Yeah.
And they're expensive.
Very expensive. Lots of mechanical engineering. Yeah. But if you think about an NPC in a computer game, that's pretty much a robot too. You can evolve them quickly. You can try out different, dimensions, different mechanisms. Everything can happen at surreal speeds, yeah, compared to the real world. So I think that the way I look at the gaming world is way beyond gaming. I'm looking at it as like what is going to be possible in the physical world, 5-10 years from now. Well, that may be possible in the gaming world next week.
That's awesome. That's great. All right, Danny. Well, thank you very much for joining us. It was great having you on the show and great chatting with you.
Oh, it was a pleasure. I enjoyed it. Thank you.
All right, everyone. That's our show for today. Once again, thanks so much for listening and for your continued support. Don't forget to leave your review or comment to enter our 1-year anniversary listener appreciation contest. The full details can be found along with the notes for this show over at twimlai.com/talk/24. Over at twimlai.com/talk/24, where you'll also find links to Danny and the various resources mentioned in the show. You are all amazing and we love you. Thanks so much for listening and catch you next time.